So in the last class, we had already gone through a lot of things like trunk port, etc. Just let's have a recap. We started with VLAN obviously, and then we looked at how to configure VLAN and how basically VLAN works along with the forwarding of the switch. Right? And then
Yes.
we discussed about the trunk port. Right? So we use trunk port when we want a switch to send out VLANs for multiple, send data for multiple VLANs. Okay, not just one VLAN, we use it for multiple VLANs. Okay, we have access mode for one VLAN, single VLAN, and trunk mode for multiple VLANs, right? And whenever a switch sends a data through that trunk port, it will always tag it with that particular VLAN ID. And how does it choose to tag? Is based on the receiving end. Okay, so we saw an example of how it chooses the VLAN tag. It is based on the receiving interface. So over here, okay, so over here we saw an example where let's say PC1 is sending a data, right? So when PC1 is sending a data, the receiving interface VLAN is VLAN number 10. So on the trunk port, when the switch is sending out a data, it will tag it with VLAN number 10 because that is what the receiving interface VLAN was, right? And with this VLAN ID only, the next switch on the trunk port will understand for what VLAN is this data coming for. And based on that, it will be able to tag it with the VLAN in its MAC address table, right? And when sending out the data, a particular switch usually sees is the receiving data or is the receiving interface VLAN and the exit interface VLAN, are they both the same VLAN ID or not? And if it matches, then only the data is sent out. Right? So we looked at the theory part, we looked at the practical side as well, right? And we left it with an interview question, right? And the interview question was, there are two switches, right? Switch one and switch two. On switch one, a PC1 is connected, and on switch two, a PC2 is connected. And both the interfaces of this switch one is on the access mode VLAN 10, and switch two also has VLANs, and on those two interfaces, it is access mode VLAN 20. So the question is, if we try to ping from PC number one, that ping 10002, will these two PCs communicate or not? Right. This was our interview question, and this is where we left.
Right, right.
So, can you guess what can happen here?
So this is looks like since like left side switch one, since both of the ports are access. So what will happen if it try to ping? It will switch will receive at the 10 and it will pass it to the other 10 because other interface is also
Okay.
10,
Yeah, yeah,
and the
correct.
data will
Okay.
data because since it is not a trunk port, it will not do a tagging. It will directly send
Right,
the data, and
right,
then the other port also it will receive. It will see that it received at 20. So it will switch will search if any other port it has on 20 or not. Then it will forward to 20. Like
correct.
since the tagging is not there, it will not do anything. It will not judge anything.
Exactly.
So
Yeah.
data come and then it will go to the two, and two will see
Correct.
data came from one. So it will try to respond to that.
Yes,
Same
absolutely.
process will happen backwards. 20
Backward.
receive and 20 will come to 10.
Yes, absolutely. So here, most of the time when people answer, okay, they they do not think from a switches perspective. They see, okay, they start to question the interviewer. Are they the same subnet? Okay, let the interviewer say, okay, yeah, they are slash 24 and they are slash, they both are slash 24. Now tell me, will they ping or not? Are they from the same VLAN? You can clearly see PCs and IP addresses do not belong to a VLAN, which we have already understood. Okay, it is the switch interface that belongs to a VLAN. Switch does not know which device is connected to that interface. It can be a PC, it can be a printer, it can be a server, anything. Okay, it doesn't matter. Okay, what matters is what is configured on the interface. Right? So people basically they deviate from the actual question of the interviewer. The interviewer asks, will they be able to ping? So they concentrate on the word ping, and they try to answer it from an IP perspective. Are they from the same subnet? Yes, they are from the same subnet. Okay, are they are they on a different geographical location? Is there a sub? Is there any router in between that I am not aware of? All these things. So unnecessarily they try to complicate the question where it is a very easy question and it has a very easy answer that you have said.
But
Now,
actually, if the IP is different, then it will be a problem, right? It will not communicate. If that is like /24 this side and the other side is 11.0.0.2, then it will become problem. Then I think it will not communicate.
even then, right? Even then, what would happen is it will try to communicate. But okay, first of all, let me try to answer our initial question. I'll come to your question later.
Okay.
Okay,
Okay. Sure.
I'll come to your suggestion if it is 11.0.0.2, it will work on. We'll try that later. But let me just concentrate on the question in. And they as I said they try to answer it from a routing perspective. Okay. And then when the interviewer says no, it's not from a routing part, everything from a different perspective, then they think that okay, this is 10, this is 10, this is 20, this is 20, so no, they will not win. Okay. And actually what happens is in the interview, the interviewer is not even going to mention if it is an access mode, if it's a trunk mode. Okay, it is you who have to ask the interviewer what mode are they configured for. Is it an access mode? Is it a trunk mode? Here, I gave all the like probable hints in the question. Right? They both are access mode. They both are access mode. So from our previous discussion, we already know that on an access mode, there can be only one VLAN. Okay. And because it is one VLAN, no tagging is done. There is no tagging. Correct. So over here, what happens when PC1 sends a data? Okay, when PC1 sends a data, assuming that PC1 and PC2 they know each other's MAC address table. Here also the switch is aware of PC1 and PC2's MAC address and it's trying to send. Right. So here what would happen is that when PC1 sends a data, it receives on interface number 10. Switch 1 sees which are the other interface which is configured for interface VLAN 10. So it is only this interface. So it will send the data. But as I said, it is an access mode interface. There will be no tagging. It will have no tag. Because it does not have any tag, switch 2 is not going to read any tag. If there is no tag, switch 2 will think it is for VLAN 20. The data that I'm receiving is for VLAN 20 because there is no tag. And since there is no tag, switch 2 will accept it. When switch 2 accepts it, it will think that the accepted data is part of VLAN 20. And which other interface is part of VLAN 20? This interface. And hence the data will be forwarded to PC number 2. The similar process will be followed in the reverse direction. Right? When PC2 responds, when PC2 responds, it is received by the switch on interface VLAN 20, access mode interface VLAN 20. It checks for other interfaces which are part of VLAN number 20 and it forwards the data. But when it forwards the data, it will have no tag. Why? Because as I said, it is an access mode. On an access mode, there will be no tagging on the data. So when switch 1 receives it, right, it will not see any tagging. When it does not see any tagging, it will think that it is for VLAN number 10 only, right? And it will accept it, and it checks which are the other interfaces that are part of VLAN 10, and this is the only interface. So it will send the data to PC number 1, right? And hence there will be a ping between PC number 1 and PC number 2. Okay, so let's see this quickly on the packet tracer. Switch 1, switch 2, PC1, PC1, 20. Let me give an IP address 10.0.0.1 and 10.0.0.2. Right now on enable, okay, on 0/1 and 0/2, we have to configure VLAN number 10. Okay, so configuration terminal. Now, because I'm going to configure, I'm going to introduce a new configuration line, which is range interface range configuration. So over here on 0/1 and on 0/2, I have to configure the same configuration, right? I have to configure them as access mode and I have to configure VLANs on them and the same VLAN. It's not different VLAN. It's the same VLAN. That is VLAN number 10. So what I can do is I can write interface range, okay, fast Ethernet 0/1 hyphen 2. So this is the range. I am saying that the range of fast Ethernet interfaces is from 0/1 to 2. Okay, if I give it as 4, it will be 0/1 to 4. That means 0/1, 0/2, 0/3, and 0/4. So over here, there are only two interfaces to 0/1 hyphen 2. Okay, then directly I can write switch port access VLAN 10. Okay, so I'm avoiding two configuration lines where, and those configuration line is VLAN 10, then switch port mode access. I'm completely avoiding these two configurations and I'm just directly writing switch port access VLAN 10. Okay, and we will see access VLAN does not exist, creating VLAN number 10. And we will see the similar configuration or similar output show VLAN. Okay, we will see a similar output where we can see VLAN 10 is configured for 0/1 and 0/2. I will do a similar configuration on switch number 2 as well. Enable, right? Then configuration terminal, interface range, that is the 0/1 and 0/2. Fast Ethernet 0/1 hyphen 2, right? So switch port access VLAN 20, right? And now we'll just wait for these interfaces to turn green, and then we'll ping from PC number 1, command prompt ping 10.0.0.2. So it is up, and let's try to ping. We are receiving a response. Okay, we are receiving a response, right? And why are we receiving a response? Let's check that. So let's do a ping once again from PC number 1 to PC number 2. Right. We are the PC created a ping packet. We'll talk about ping in detail later. Okay. However, we are only going to concentrate on the the first header, that is the Ethernet header. So this is the destination MAC address, which is PC2 MAC address. This is source MAC address, which is PC1 MAC. And over here, we can see there is no VLAN ID mentioned. Right? There is no VLAN ID mentioned over here. Now let's forward the packet. The packet is received by switch number 1. And let's open the packet over here. The input or the inbound packet, there is no VLAN over here, right? In the inbound packet, there is no VLAN mentioned. Is a VLAN mentioned in the outbound packet? We can see no. There are no VLAN ID mentioned in the outbound packet as well. That means there is no tagging. If there was a tagging, we would have seen a different header named TCI, tag control identifier, which we had discussed when we were discussing the VLAN part, right? Tag control identifier. Okay, so TCI, tag control identifier, that header is not present, meaning that this particular packet in the outbound direction is not tagged with any VLAN. And since it is not tagged with any VLAN, okay, when switch 2 receives it, it will see that there is no VLAN tagging. When there is no VLAN tagging mentioned, it assumes that this data is for VLAN 20 only. This data is for VLAN 20 only. Okay, so it accepts the data, and it forwards to PC number 2. PC number 2 receives it. PC number 2 sends back the data, right? Again, on switch number 2, we can see the receiving data does not have any VLAN. The sending data does not have any VLANs associated to it. And it will forward the data to switch number 1. Switch number 1, because it does not see any VLANs on the Ethernet header, right? It assumes this particular data is for VLAN number 10, and it forwards the data to PC number 1. And hence, we will see a ping reply from switch number 2. Sorry, PC number 2. Got it?
Yeah, got it. Yeah, this is clear.
Yeah. To even better understand this in a real-time manner, okay. Imagine that you are living in a house or you are living in an apartment. You are living in an apartment and you are the sole person who is using this apartment. And there is a security guard. Okay, there is a security guard. His work is to monitor who goes in the house or who goes inside the apartment and who comes out of the apartment. Right? We have security guards for our society, and they basically monitor. Right? They check our IDs and they send messages to the owner of the house or owner of the apartment that some guest has come to your apartment and is standing at the gate. Should I let him in or not? Right? So these kind of messages are sent to the society's app. Think from that perspective. This building, imagine this as a switch. Imagine this switch. Imagine this as a switch. Now, you are the only person who is entering this building and who is coming out of this building. Right? Will this security guard check your ID? No. Why? Because you are the single person who is entering this house and exiting out of this house. Right? Exiting the house and entering the house. So there is no need for the security guard to check your ID because he knows you. That is what access mode is, or access VLAN or access mode is about. It is only one VLAN. It is only one VLAN. That is why the switch is not even bothering to check which VLAN does the data belong to, because that is the only data that can enter and that can exit out of it, which is VLAN number 10, which is VLAN number 10 from switch 1's perspective. And from switch 2's perspective, it is VLAN number 20. But let's say now in this apartment, there are multiple residents now. There are multiple people living in the house or in the apartment. Let's say 100 people are there. Okay, 100 people or 100 VLANs are living in the house. So every time a person tries to enter the apartment, the security guard has to check the ID. Right? The security guard needs to check the ID. Similarly, this checking of ID is what a trunk mode does. Okay, because there are 100 VLANs, 100 of residents living in this apartment, the security guard needs to check their ID before letting them in. And that is what the switch does when that interface is configured for a trunk mode. It looks for an ID. do I know this ID or not? Do I know this person or not? It's the same way that the access mode and the trunk mode are basically working here. The access mode, in the access mode, it knows that there is only one VLAN that is configured on the interface, and that VLAN data only can enter. That VLAN data can only enter through the through that interface. And on switch one's case, that was VLAN number 10. So it is not checking. It is not checking. And in switch two's case, it is 20. So it is not checking, because when they are sending out the data and when they are receiving the data, there is no tagging. Got my point? Now let's think from this perspective. Okay. This is access mode. Let that be access mode. And let this be a trunk mode. This is trunk mode. Okay, with VLAN number 20. Here also VLAN number 20. Okay. Now when okay, now when PC2, let's from this perspective, now let's say PC2 is trying to ping. PC2 is trying to ping. Ping 10.0.0.1. Now what is going to happen? Can you tell me?
So here also two cases can come, right? Here, once like PC2 pings and once PC1 pings. So that
So
both different
we are
side.
looking from a PC2's perspective. PC2
So
is pinging first.
PC2 is pinging first. So first
Hmm.
pinging, then it will go to the first port VLAN 20, then it will come to the 20.
Hmm.
And since trunk port, it will tag it with 20 and
Okay.
send to the other side. So other
Okay.
side, but other side won't understand the tag. What will happen to this? This will not know what to do with this. So this is access mode, right? The access
Correct.
mode
You're
tag is
absolutely right.
there. Uh, like it will not be able to pass it to this one,
Exactly.
system one.
Exactly. Exactly. So you're absolutely right. So over here, when it is a trunk port, right? PC2 sends the data, switch 2 will accept it from an access mode 20 VLAN. And because it is access mode or the receiving interface VLAN is 20, when it
20,
is sending the data out of this interface, it will tag it with a VLAN ID 20.
20.
Correct. When this data is sent, switch 1 will see the tag. It will see VLAN number 20 because now it has been tagged with VLAN 20.
20.
But switch 1 now knows that this is an access mode and only VLAN 10 data can enter. But in the receiving data, the tag is 20.
20.
I will not allow it.
Oh, it will stop there itself. Okay.
It will stop there itself. It will not allow. Okay, it will not allow it. Now, so if here this is a trunk mode, okay, on a trunk mode, VLAN ID is tagged. And in when VLAN ID is tagged, switch 1, when it receives it, it sees the tag. When it sees the tag, it sees that the receiving interface VLAN is 10, but the receiving data is VLAN 20. I'm not going to accept. Okay, this is one scenario. Now, the next scenario, what if we are pinging from the other side? Okay, what if I ping PC2? Okay, now the data is sent. Switch 1 will not tag it. It will not tag it with any VLAN because this is access mode. Okay, now switch 2 will receive it. When switch 2 receives it, it does not see any tagging. It does not see any tagging. When it does not see any tagging, it basically questions itself. It questions itself. I have been configured for a trunk mode, okay, where I can allow VLANs that are tagged with VLAN 20. Okay, now think from switch 2's perspective or think from this guy's perspective. this security guard. Imagine there is a person. Okay, imagine there is a person who is entering the house, but then the security guard stops him. He stops him and he asks for an ID. But this guy says that I don't have an ID. What will the security guard do? Okay, what will the security guy do?
Actually, he should not
So,
allow if no ID. He should not allow to come.
correct. He should not allow if there is no ID. Absolutely right. But in switch, in switch, there is a concept called as native VLAN. Native VLAN. Think of this native VLAN as the owner of the building, owner of the whole building. Okay. If he is the owner of the building, he can freely enter the house, or he can freely enter the apartment, and he can freely exit out of the apartment. The security guy does not need to check his ID, or this owner does not need to carry an ID. Similarly, the switch over here, it will see if there is no tagging over here. If there is no tagging over here, what is the native VLAN configured on switch number 2? What is the native VLAN configured on switch number 2? And by default on Cisco switches, on trunk port, on trunk port, the native VLAN is VLAN number 1 on Cisco switches. On Cisco switches, it is native VLAN number 1. All right, it is native VLAN number 1. Clear?
So,
Is
so,
this confusing?
so, so what it will do with this native VLAN? Like VLAN, we have
Yeah.
configured only 20 this side, right? So we
Here
don't have any.
you have configured trunk mode VLAN 20. Okay. And by default, okay, let me explain you with the here enable show interfaces trunk. Let me change this to a trunk interface. Configuration terminal interface pass net 0/2, no switch port, access VLAN 10, switch port mode trunk, switch port trunk, allowed VLAN 10, show interfaces trunk. Okay, so over here, when we were discussing about trunk and VLANs lately, I said leave these 3 lines for now, right? This is what I had mentioned earlier. Now let's concentrate on the first line. So it says show interfaces trunk. We can see the first this interface 0/2. Okay, the status is trunking. It's a trunk port with a native VLAN of 1. Native VLAN of 1. Okay. Now, what does native VLAN exactly mean? It means that if there is a data that is to be sent out or received without any tagging, please listen to this very carefully. If there is any data that needs to be sent out or received without any tagging, that can be only VLAN number 1. So, for example,
Send out, how it is? Send out, it will try to send it. It has that trunk VLAN 20.
yeah,
It will send to the VLAN 20 only. So, how it will send to one out incoming? Okay, incoming
so
it
over here,
came.
let's say there is another PC. Okay, and if you remember, by default, all the interfaces of a Cisco switch are VLAN
VLAN
number
1.
one,
VLAN 1,
right?
yes.
So let's say this interface is 0/3. For example, this interface is 0/3.
Okay. And that is VLAN 1.
That is VLAN. When this PC sends a data, the receiving interface is VLAN number one, right?
VLAN 1.
And when it is sending the data out, it sees that the receiving interface is VLAN number one. That means when sending out, I need to tag it with VLAN number one. But as per my native VLAN configuration, my native VLAN is VLAN number one. I will not tag this with any VLAN. I will not tag this with any VLAN.
Okay.
So, right, any data that is sent from or received on these interfaces, which are part of VLAN number one, on the trunk interface, they will not be tagged. They will not be tagged.
Okay.
Okay. Or let me explain it in a much better way.
The right side was a
Yeah,
trunk and left side was
yeah,
a
yeah.
axis.
Let me explain that in a better way.
A little bit is confusing.
Yeah, yeah, yeah. I know. I got it. Okay. Switch one, switch two. Let me bring two PCs. Okay. PC number one, PC number two, PC number three, and PC number four. Okay. This is 10. This is 20. Okay. This is 10. This is 20. These two interfaces are trunk interfaces. Okay. Trunk interface, trunk interface, trunk interface with VLAN 10 and 20. Okay. Is this diagram clear?
So this means both side is a trunk and both having 1020 both.
Correct.
Okay.
10, 20, both. So they will be sending data. When they are sending the data out, they will send it with VLAN 10 and VLAN 20, tagging it with VLAN 10 or VLAN 20. Okay. I hope this diagram is clear.
Yes, it is clear.
Yeah. Meaning that when PC2 sends a data, it will see the receiving interface VLAN, that is 20. When it is sending the data out, it will tag it with VLAN 20. If the receiving interface VLAN is VLAN 10, when sending out, it will tag it with VLAN 10. Okay. Clear? Any question with
Uh,
this topology?
this, yeah, this is fine. So same will happen from right side also. If
Yeah,
PC4
yeah.
wants
Same
to send,
thing
it
will
will be
happens
10.
for switch 2 also.
Right side. Yeah.
Same thing happens for switch 2 also. Right. So when PC3 sends a data, it will see the receiving interface, and when it
Correct.
sends the data out, it will tag it with VLAN 20.
20.
When PC4 sends the data, it sees the receiving VLAN as 10, and when sending out to the trunk interface, it will tag it with VLAN 10.
10.
Okay. Now, as I said, on Cisco switches, all the interfaces are part of VLAN number one. Let me bring a new switch over here. Okay, switch number three. Okay, and you can see there is no connection. I have not connected any PCs to it. However, let me just show you the VLAN table. Let it boot. Okay, enable, show VLAN. And you can see here that all the interfaces, all the interfaces by default are part of VLAN number. By default are part of VLAN number one. Is this clear?
Yes.
Okay. So the moment I connect any PC or any device to any of these interface, that interface is part of VLAN number one. Clear? So if I connect PC3, PC4, PC5 over here, anything, and if I just simply connect all these PCs to the switch, all these switch interfaces then automatically become part of VLAN number one. So I can just ping these three PCs together. There is no problem because All these interfaces are part of VLAN number 1. Okay, which we can clearly see on the show VLAN, which we can clearly see on the show VLAN, which is 0/1, 0/2, 0/3, 0/1, 0/2, 0/3. All of them are part of VLAN number 1 by default. Okay, is this clear?
Yes, it's clear. Yeah.
Now let me bring or connect one more PC over here. Let's say this is PC number 3, PC number 4. So this is PC number 5. And over here, let me connect it with PC number 6. And I'm not doing any configuration. So we just saw all the interfaces of a Cisco switch is part of VLAN number 1. So what will happen? Naturally, this interface will be a part of VLAN number 1. Here also, this interface will be part of VLAN number 1. Are you with me here? Clear? Any
Yes.
question?
Yes, still it is clear. Yeah.
Clear. Now, what if PC5 pings PC6? When PC5 pings PC6, switch 1 will receive it. Okay. Switch 1 will see that the incoming interface is VLAN number 1. So when it is sending out of the trunk interface, no tagging will be done. Why? Because the native VLAN is VLAN number 1. So on the trunk interface, any data that is received on VLAN number 1 interface, when it is being sent out of a trunk port, there will be no tag attached to the data. When there is no tag attached to the data, switch 2 will also automatically assume that since there is no tagging involved in the data, this data belongs to interface VLAN number 1 and it will forward the data to PC6. Similarly, when PC6 responds, it sees that the receiving interface is VLAN number 1. That is my, on the trunk interface, it is my native VLAN. So when I'm sending out the data, again, there will be no tagging involved. When there is no tagging involved, switch 1 receives it. It will see no tagging. When there is no tagging, switch 1 will automatically understand that this data belongs to VLAN number 1 interface and the data will be forwarded to PC number 5. Got it?
Yeah, got it. It's clear.
Yeah.
But now, if we
Let's
go to the
yeah.
above picture, that previous one, here, if
Yeah.
I add one more PC in the left side, that
No,
will
let's
also
not
go.
add PC. Let's try to solve this
Okay.
from whatever understanding we have of native VLAN, trunk port, and access port.
Okay. Okay.
Okay, let's try to solve it, and then we'll add more and more situations into the place. Okay, now as I said, this is access mode, VLAN 10. Okay, when it sends, this is access mode, so no tagging is there.
No tagging,
No
right?
tagging is present. When, please remember, this is an access port, this is a trunk port. So on the trunk port, it is looking for a native VLAN. Native VLAN will not have tagging, correct?
Tagging. Yes.
Native VLAN will not have any tagging. And by default, what is the native VLAN? It is VLAN number 1.
1.
Correct? So it sends the data. Switch 2 will accept it. Why? Because there is no tagging. And because there is no tagging, it assumes it to be part of VLAN number 1. It assumes it to be part of VLAN number 1. It accepts it. However, because it is part of native VLAN and as per switch 2's configuration, native VLAN is for VLAN number 1. It will not be forwarded out of here because it is part of VLAN 20. It is part of VLAN 20.
since only one PC is there with VLAN 20.
Correct. If there was another PC and I have not configured any VLAN, the data would be forwarded here.
But forward, it will not see that it is coming from 10. No, it will not be
No,
able to
it
see
is
because
not
there's no
C
tag.
because there is
Because
no
no tag
tagging.
is
There
there.
is no
Because no
tagging.
tag is there. Okay, yeah, because no tagging. So it will see the data directly came. It will send it to
Yeah,
one. Okay, got it.
yeah.
Yes.
When it sees no tagging on, because this again, please remember, I'm emphasizing on the word. This interface is a trunk mode. On a trunk mode, by default, the native VLAN is supposed to have no tagging, and
No
by
tag.
default, that VLAN tag is VLAN number 1. And because there is no tagging involved, this switch assumes there is no tagging. So it must be part of VLAN number 1. I must accept it. It accepted it. But in our original diagram, there was no other interface
No other.
with VLAN number 1.
So it will drop it.
It will drop it. It will not drop it. It will not be able to forward it. It
No,
will
it
not be
doesn't
able
have
to
any.
forward it.
It doesn't have any port. Okay. It will just process
Exactly.
and stop there.
Exactly. Exactly.
So in this case, we mean that from 10 to 1, we can communicate through different VLANs also. Like, like
From
normally
PC1 to
we
PC20.
no PC one more. If we add one more in PC3, that will be in VLAN one
Where?
native
Switch
VLAN
1 or switch 2?
switch to right side. If we add
Okay.
that, will go
Switch
to
2.
native VLAN one by default. So
Correct.
now the thing, if PC1 communicates to PC3 means from VLAN 10 we are able to communicate with
Yes.
VLAN 1.
Yes. Yes.
Otherwise, the VLANs like normally segregate the thing. Like VLAN 10 can go in 10, 20 can go with 10, 20.
Correct.
But here
Correct.
it is happening opposite. It is going like it can communicate VLANs without.
Yes. Yes. Again, however, this is not the recommended practice. You can clearly see there are so many loopholes. There are so many loopholes, right? So it is always recommended, if you are connecting two switches together, always connect them using a trunk port or a trunk mode.
Both side trunk.
Both side trunk, so that at least tagging is present. Otherwise, you can clearly see the loopholes here. You will always create access mode when you are connecting to end devices. But if it is between switches, it is always
Always
recommended
trunk.
to have trunk.
Trunk.
Okay. Now, again, whatever we just read, let me do that in a practical way so that it is easier to understand. Switch number 1, switch number 2, PC, PC2, PC3, PC4. Okay. So what I'm going to do, this is VLAN number 10, VLAN number 20. This is trunk mode, VLAN 10, VLAN 20. This is also trunk mode, VLAN 10, VLAN 20. This is VLAN number 10, and this is VLAN number 20. Okay, I hope the diagram is clear. So, so on switch number 1, okay, enable configuration terminal interface fast Ethernet 0/2 switch port, access VLAN 10. Okay. Then exit, interface, fast Ethernet 0/3, switch port, access VLAN 20. Okay. Exit, then interface, fast Ethernet 0/1, switch port, mode, trunk, mode, trunk, then switch port, allowed, switch port trunk, allowed VLAN all. Meaning that on this particular interface or this particular trunk interface, I'm allowing every VLANs, not just 10 and 20 and 1. I'm allowing VLANs from 1 to 4096. Okay. I'm allowing just every VLAN. Makes things easier. Right? You can also configure specifically like VLAN 1, VLAN 10, VLAN 20, like that also. But over here, I configured it for all VLANs. A similar configuration, I'll do it on fast Ethernet, switch number 2 as well. I hope you are able to follow this.
Yes.
Interface, fast Ethernet 0/3, switch port, access VLAN 10, exit, interface, fast Ethernet 0/2, switch port, access VLAN 20, exit, interface, fast Ethernet 0/1, switch port, mode, trunk, switch port, trunk, allowed, VLAN, all. So when I say allowed VLAN all, let's check what is the what changes do we see in the show output. Show interfaces trunk. To see trunk interfaces, you have to write this show interfaces. You cannot see trunk VLANs on show VLAN commands. Okay. So over here you can clearly see this says on fast Ethernet 0/1, trunking is enabled with native VLAN 1. How many VLANs are allowed in this trunk? From 1 to 1005. Okay, not 4096. Why? You can see show VLAN. Okay, so from 1 to 40, 1 to 005. The other VLANs from 1006 up till 4096, they are called as extended VLANs. They're called as extended VLANs. I'm not going to talk about extended VLANs as of now. Okay, but just understand there are VLANs from 1 to 4096. Okay, 4096. Okay, from 1006 to 4096, they are called as extended VLANs. All right. So in our show interfaces trunk, we can see the allowed VLANs are 1 to 1005. But on that particular interface, the VLANs that are active are 1, 10, and 20 because those are the only VLANs which are configured. One is the default VLAN, which we did not configure, but it is already present. The two other VLANs that are allowed for a management domain, do not worry about what is a management domain. I'll explain that later. But what are the VLANs that are allowed and active? That are 1, 10, and 20. 10 and 20 we explicitly configured. 1 is already present. So these are few information that you can see over here. All right. Now, let me give IP addresses to these PCs, which I have not done yet. 10.0.0.1. This is 10.0.0.2. PC number 4. 10.0.0.4. PC number 3 is 10.0.0.3. Now let me ping PC1 and PC4. Ping 10.0.0.4. We are receiving a response. Correct. Similarly, let me ping PC2 and PC3. I'll show you in the simulation mode as well. Ping 10.0.0.3. We're receiving the response. Now let's see from a simulation point of view. So PC number 1, let's do a ping again. When I do a ping, a ping packet is created, right, with PC4's MAC address and PC1's MAC address. Okay, so this data is forwarded. When switch 1 receives this data, let's see the incoming details. Here you will see in the incoming detail, there is no VLAN attached. There is no VLAN attached to it, right? And let's check the outgoing details. In the outgoing detail, see here, in the incoming detail, there was no VLAN attached, but in the outgoing detail, you can see a VLAN attached. TCI, tag control identifier, with a hexadecimal value of A. A means 10 in hexadecimal, right? You can clearly see there is a tag mentioned there. VLAN tag is present. Okay. Why VLAN 10? Because the receiving interface VLAN was 10 and hence the outgoing interface on the trunk port is also tagged with VLAN number 10. I hope this is clear. Now this data is sent. Okay. Switch 2 will accept it. Why will it accept it? Because the incoming detail, it sees the VLAN ID as 10. And on its trunk interface as well, on its trunk interface of switch 2, the VLANs that are allowed and active are VLAN 1, 10, and 20. Also, this VLAN that is allowed on this trunk is between 1 to 105. 10 obviously comes in between 1 and 105. Hence, the switch accepts it. And when it accepts it, it looks for other interfaces that are part of VLAN 10, which is interface 0/3, and the data is forwarded to PC number 4. PC number 4 responds. The switch sees that. Please remember, these two are access mode interfaces. Only the link between the switches are trunk interface. The other interfaces which are connected to the PCs, they are trunk interfaces. Sorry, access interfaces. Okay. That is why let me go back to our previous condition. When switch 2 is forwarding the data, you can see the incoming data from switch 1. From switch 1 to switch 2, it had a VLAN tag of VLAN 10, right? But when it is forwarding the data to PC, you will see there is no VLAN tagging. Why? Because it is an access interface. On an access interface, there is no VLAN tagging. That is why when it is forwarding the data out of that interface, there is no VLAN tags mentioned. All right. Now it has received a PC4. PC4 sends it back to switch number 2. Switch number 2, upon receiving, it checks the incoming interface. Incoming interface is for VLAN number 10. So it tags it with a VLAN number 10 when it is sending it out. Right? When it sends out, PC switch number 1 receives it. When switch number 1 receives it, it will see a VLAN tag of VLAN number 10. When it is forwarding the data, out of an access interface, and hence it has removed the VLAN tag. And the data is forwarded to PC number 1. Right. The similar case, we will see it for PC2 and PC3 as well. Same way. PC2 sends the data. The receiving interface is for VLAN number 20. So when it is sending the data out of trunk, it will add a VLAN 20 to it. Switch 2 will accept it because it will see VLAN 20 in the tagging. And it looks for another interface which is configured for interface VLAN 20, and the data will be forwarded to PC3. PC3 will respond. Switch 2 will accept it. It will see the incoming interface is VLAN 20. So when it is forwarding the data out of the trunk interface, it will tag it with VLAN number 20. Switch 1 will accept it because it will see the VLAN tagging 20. And on the trunk interface, it is allowed to accept VLAN 20. And it will see which is the other interface which is configured for VLAN 20, and it will forward the data to PC number 2. All right. Are these steps clear?
Yes, they still this much is clear.
Right. Now, let me add PC number 5 over here and PC number 6 over here. We give them some IP addresses. 10.0.0.5. PC number 6. 10.0.0.6. Let them come up. PC number 5 is up. PC number 6 is also up. And just look at it. I have not configured anything on the switch for the two interfaces. Okay. On 0/4, I have not configured anything on switch number 1. Same for switch number 2. I have not configured anything on 0/4 of both these switches. I just connected the two PCs to the switch interfaces. Okay. And let me ping from PC number 5 to PC number 6. And we are seeing a response. We are seeing a response. Why? Let's check that. Simulation mode. Okay. Ping. Right. PC5 sends the data or creates the data. Okay. This is PC6. PC6's MAC address, and this is PC5's MAC address. Again, there is no VLAN tagging. And as I said, end devices like PCs, they do not understand VLAN. Who understands VLAN? It is switch. So obviously, PCs will not add a VLAN over there. Switch 1 will receive it. When it receives it, let's open the show VLAN table for switch number 1. Show VLAN. And we can see 0/4 is configured for interface VLAN 1. Okay. And as per the show interfaces trunk output, native VLAN is 1. That means on this interface, when the receiving interface VLAN is VLAN number 1, the outgoing interface, if it is a trunk interface, the outgoing interface, if it is a trunk interface, there will be no tag for VLAN number 1. For VLAN number 1, there will be no tagging, and let's see that over here. Incoming details, you can see there is no TCI, tag control identifier. Outbound detail, I have clicked the outbound detail. Okay, I'm on the outbound tab, and you can clearly see there is no VLAN tagging. There is no VLAN tagging. Why? Because the native VLAN was for 1. Native VLAN is 1. Meaning that any data that is received on the native VLAN interface, the trunk port is not going to tag it with a VLAN. The trunk port is not going to tag it with a VLAN. Right? So the switch forwards data. Switch number 2 will receive it. And again, when switch number 2 receives it, when switch number 2 receives it, it will open the packet. It will open the packet and it will not see any VLANs to it. When it does not see any VLAN to it, show interfaces trunk. It sees that if there is no VLAN to it, that means it is part of VLAN number 1. That means this data belongs to VLAN number 1. And which is the other interface which belongs to VLAN number 1? That is 0/4. And the data is forwarded to PC number 6. PC number 6 response. 0/4 is for VLAN number 1, right? When switch 2 forwards the data, When switch 2 forwards the data, no tag is provided. Let's check. Let's open the packet. You can see the inbound. This is from the switch 2 side. Switch 2 has not sent any tagging to it. When switch 2 has not sent any tagging to it, switch 1 will automatically assume that it is part of VLAN number 1. Why? Because I just showed you switch 1's interface, show trunk interface configuration, not configuration, output. It is VLAN 1. VLAN 1 data will not be tagged. So switch 1 assumes it is part of VLAN number 1 and forwards the data to PC number 5. Clear? So on trunk interfaces, native VLAN are not tagged. And the native VLAN should be same on both sides. On both the interfaces, the native VLAN should be same. Here, it's like, here if it is 1, okay, it's a default. VLAN number 1 is the default native VLAN. It is the default VLAN. I can change it. I can change it to any other VLAN also. So let me show you that. On switch number 1, let me change the native VLAN to VLAN number 10. Okay, configuration terminal. Okay, interface fast Ethernet 0/1, switch port mode, switch port trunk. Yeah, we can see switch port trunk native. I'm telling this interface, on this interface now the native VLAN is VLAN number 10. That means now VLAN 10 data will not be tagged. VLAN 10 data will not be tagged. Okay. Similarly, on this switch also, let me configure the same. Configuration terminal, interface, fast Ethernet 0/1, switch port, trunk, native, VLAN 10. Switch to 0/1. Okay, native VLAN 10. And show interfaces trunk. Now you can see instead of 1, now it is 10. Instead of 1, now it is 10. Now let's try to ping from PC1 to PC4. Okay, before I move ahead, are you with me till here?
Yes, it's clear till now.
Okay, now let's ping from PC1 to PC4. Earlier, when I received the data here, this was interface number 10. And when I was sending the data out, it was tagged with VLAN number 10 in a hexadecimal form of 8. Correct? Now let's see what is going to happen. Command prompt ping 10004. Okay. The data is forwarded to switch number 1. Switch number 1 receives it. It sees that it was received on an interface which is access VLAN 10. Now, I have to forward this data out of the trunk interface. But on my trunk interface, it says that the native VLAN is VLAN number 10. So should I tag it or not? See the inbound detail again. There is no VLAN tagging. Is there any VLAN tagging in the outbound detail? No. There is no outbound tag. In the outbound detail also, there is no VLAN tagging. Why? Because I changed the native VLAN to 10. I changed the native VLAN to 10. So now VLAN 10 data is not tagged. This data is forwarded to switch number 2. Switch number 2 will not see any tagging. When it does not see any tagging on switch number 2, native VLAN is 10. That means it assumes if there is no tagging, this data belongs to VLAN number 10, and which is the other interface which belongs to VLAN number 10, that is PC number 4 interface. So the data is forwarded to PC4. And the same happens in the reverse direction. And the two PCs are able to communicate. We'll see the two PCs are able to communicate. Now, the question you may ask is, what about PC 5 and 6? Will we see a tag? Yes, you will see a tag. So now let me ping from PC 5 to PC 6. Okay, PC 5 sends the data. This is VLAN number 1. Please remember, this was VLAN number 1. This was VLAN number 1. Okay. Now on the trunk interface, it is supposed to forward the data. Will it tag or not? Let's check that. So inbound details, there is no tagging. But in the outbound details, you can see a tag control identifier, TCI of 1. Earlier, VLAN 1 was a native VLAN. That is why we did not see any tagging. But now VLAN 10 is a native VLAN, but VLAN 1 is no more the native VLAN. And hence, on the trunk interface, you are seeing a tag. You are seeing a tag. Okay, with a VLAN tag of 1, it forwards it to switch number 2. Switch number 2 will receive it. It will see VLAN tagging of 1. It will see a VLAN tagging of 1, and which is the other interface which is tagged for VLAN number 1, that is this interface, and hence the data is forwarded to PC number 6. The reverse is the same. It will be tagged with VLAN number 1 when switch 2 is forwarding the data to switch number 1. You can see here the outbound data. Switch 2 is supposed to forward this to switch number 1. We are seeing a VLAN tag of 1. The data is forwarded to switch number 1. Switch number 1 forwards it to PC number 5. And hence the two PCs are able to communicate. Clear?
Yes, it's
Any
clear.
question?
Yeah, till now it's clear now.
Yeah. So any interview question they may ask with this type, if your concept of access mode, trunk port, and tagging is clear, no matter what question they throw at you, you can easily answer. Okay. So the different situations that we were coming up with is we were discussing in today's class. Switch 1. The first scenario was a very simple scenario. Switch 2, PC 1, PC 2. This is again access mode 10, access mode 10, access mode 20, access mode 20. Will they be able to ping or not? PC1 and PC2, will they be able to ping or not? We just discussed, yes, they will be able to ping. Because this is access mode, access mode, access mode, no tag. So they are able to ping. Then we discuss another scenario where this is trunk mode. This is trunk, but this is access. What is going to happen? No pinging will happen. No ping. Why? Because when switch 2 forwards the data, it will tag it with VLAN 20. Correct? It will tag it with VLAN 20. But when switch 1 forwards data from PC1, if it is forwarding the data, okay, it will not tag. It will not tag. Correct? Now, think from this perspective. This is access mode. It is not going to tag. No tagging. But this is a trunk port. What is switch 2 going to do? It sees that there is no tagging. Is my native VLAN. Native VLAN. What is my native VLAN? It is VLAN number 1. It is VLAN number 1. Okay. By default, on, as I said, by default, it is VLAN number 1. And because there is no VLAN tagging, switch 2 will accept it because it does not see any VLAN. It does not see any tagging. It accepts it. But on this switch, there is no other interface which is for VLAN number 1, and hence the packet is dropped. And hence the packet is clear.
Yes.
All right. So with this, we are finished with VLAN, access port, and trunk port, and different tricky scenarios that they may ask you. Do you have
One
any situation in
okay,
head?
one more thing is like if in left side now the same thing I was asking earlier. So if left side switch one, we add one
Hmm.
more PC and that will by default in VLAN one.
Correct.
Okay. Now and right side if we add one more PC,
Hmm.
that also will go in VLAN one. Now will these two communicate? Switch two
Yeah, they
like
will be
switch
able to
three and
communicate.
four. So switch two has switch like left side is a switch three and right side is switch four. There is one two already there.
Uh,
So the three and four will it communicate the device switch? Sorry, it's not switch.
hold on. One, two,
One two is already there. This one
one, two.
three
Yeah,
and
yeah.
that is four.
Give me.
Three and that one is four.
Hmm.
Okay, so now the thing is three and four will communicate or not.
Okay. Now again the question: are we keeping them as access or trunk?
The same situation how it is now. One side access and one side trunk.
One says trunk. Right. Again, no, they are not going to communicate. They are not going to communicate. First of
So
all,
it will
why?
stop
Okay.
where? It will stop
Why
where
will
it
they
will.
now be? Okay. Let's on PC number three ping PC port.
Yes, right.
If we
Basically.
do this, the receiving interface is VLAN 1. The sending interface does not have, there are no other interface which are part of VLAN number 1. It's not even going to forward the data.
Okay, it will get dropped at their point itself.
Yeah, it's going to drop at switch number 1 itself.
Okay,
Okay.
and if I change this port to access, then it will allow the thing. Left
If you
switch,
see,
switch one. If I make from access to trunk, then it will allow to system to
yes,
hold.
yes, it will.
Then it will do
Okay.
the like it is will do a default thing native, and then native it will
Yeah,
directly go
native
without
VLAN.
this.
Yes, native. Now, again, let's think from the other side. What will happen? This is access port. So it
Okay, it
forwards.
starts from
Okay,
port.
it forwards PC4. Okay, this is VLAN number 1. Okay, when it is forwarding the data out of trunk port, this is native VLAN, so no tagging.
and
Correct?
and
No
that side it
tagging.
is 10.
Okay, so here it
So
receives it again. This is access port, so there is no tagging. It does not care. It
it
does
will
not
not
care.
allow. It will not allow
It will
itself.
allow. It will allow because there is no tagging. Here there is no
No,
tagging because
no,
this was a
but that
native
is
VLAN.
access. It will allow only one single thing, but it is coming as a one.
No, it will not come as one. As I said, on the trunk interface, the native VLAN is one. It's not going to tag it. I just showed you
Okay,
on the
yes,
practical.
right, right. It will receive it. It's right. It will receive and it will
Switch one will
has
receive it.
one. It will send. It will send to one
Switch
also.
one will send it. Okay, switch one will receive it because it does not see any tag. And the next moment, it will see the MAC address. What is the destination MAC address? It will see PC3's destination MAC address and forward it.
Yeah, because port one that VLAN one is already existing there.
Yes. However, the return will not be able to possible. Will not be possible.
No, only ping will come, but it will not be able to return. Yes, right.
Exactly.
Return will get blocked.
Yes. Return will be blocked. Got it?
Got it. Yeah, got it. Clear.
All right. This was a great interactive session and a lot of tricky interview questions were handled.
Yeah, these things, lot of things got clear in this VLAN
Hmm.
this thing.
Happens. Like as I said, many times the questions that I see in the interview from the switching point is this. They dig you down so much with just VLANs. It's horrible.
Because
So
it's
as
very
I said,
small,
if
small
so
concept.
as I said, if as I said, if your concept of what is an access port, is there a tagging involved? What is a trunk port? Is there a tagging involved? When is a tagging involved? When is not a tagging involved? If all this thing is clear, any tricky question thrown at you like this, you will be able to answer it very easily. But the only thing is, if limited information is given to you, you have to ask the interviewer, this is what,
What
this is
what
what are you assuming? Am I assuming the right thing that as you yourself? You have to ask these questions.
Okay. And
Do they
then we have
do?
to get this
Is
this
this an
clear.
access
Then
code? Is this an access code? Is this a trunk code? If this is a trunk code, what is the native VLAN? All these questions you have to pull out from the interviewer's offer.
because they will not provide everything. They will just give one
Exactly.
thing and
Yeah,
okay.
that's what. All right. So that's it for today's class, and I'll see you tomorrow.
Okay. And what will the topics for tomorrow?